This is a recording for my capstone project in the Coursera Java programming specializations. So the project is about the analyzing the social network data, as you can see in the screen. For this project, I use the data of UC San Diego Facebook data. Maybe we can quickly see how the data looks like. So the Facebook data is like this. It's very simple. You only have the indexes, which represent the people in the Facebook. So you only have the vertex in the network and also the edges of those peoples, and then we don't have any other particular information but the Facebook. So it contains 14,000 people, as you can see here, and usually each people have average number of people about 60. So this data is kind of big. So the question I wanted to answer in this project is how the diffusion of technology is going to occur in this network, which is called cascade. Cascade is diffusing information. So we can touch on the concepts. So that we can model this cascade like this equation. So here P means the proportion of your neighborhood who are using the new technology A. We assume we only have two technology, new technology A and also old technology B. So P is a proportion of new technology people using. And then B is a payoff of using old technology B, and A is the payoff for A. So this equation means that if the proportion of people who use the new technology is bigger than the payoff of old technology proportion, you should switch to a new technology. So this algorithm is not only looking at how your neighborhood is reacting to the new technology, but also it's looking at the 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 value of using the new technologies. So I think this is intuitive, right? So this algorithm is depending on how the proportion is going to be and also the payoff of A and B. So I try many different combination of this, and P is controlled by the initial adopters of new technologies. And then inside the cascade algorithm, we are gonna iterate the same process. Maybe we can just see the code. So this is the method for the cascade. So as you can see, we have payoff A and B, and then this threshold was the right hand side of the equations. So I think we just use the while loop and also for loop to go to many people in the Facebook, and then every time you check how many neighborhood using the new technology A, and then what is the ratio. So this if conditional statement is the equation we just saw. So P is the n threshold. But and also I don't want to have a duplicate stuff. So set A contains the hash map of the people using the new technology, and then if the condition is satisfied, we are going to put we convert all people, and they are going to be the people who are using the new technology A, and then we push it to the hash set of new technology people. So we can quickly see the result. So this is a table. So I try many different number of initial adopters and also different the value for the payoff A. And as you can see, if you increase payoff A or if you increase the initial adopters, we can have more higher value. So the ratio inside the table is a ratio of, after the iteration, the number of people who are using a new technology divided by the total number of people. So So if the number is bigger, we can see a cascade is really cascaded to entire network. But as you can see, we only have very small ratio or super big ratio. So I'm a bit disappointed because I couldn't see a nice coexistence of new technology A and B. So this result is kind of different from we actually see in the real life. For example, some proportion of people using the iPhone and some proportion of people using the Google Pixel. So there is a nice coexistence. You cannot see almost all the people using the iPhone. Well, maybe that's true, but anyway. So that's so I wanted to know why this is happening, and that was the kind of difficult part to explore because the data is big and I didn't have nice visualization tools. So what I did is I made many helpful functions, just get the how many people in some sort of sets and why this is occurring. And one thing we can mention is there's an isolated network within this UC San Diego Facebook data. So these 8 people, they just connected with each other and then they don't have any other friends. This is a really unique data inside the network. So that is why if those people are not chosen as initial adopters of A, the cascade algorithm is simply cannot reach them because they're isolated. So that is why I cannot diffuse the technology to the entire network. So that is why we saw 0.99. Yeah, so maybe I talked too much. So yeah, so as a recap, so my project is about analyzing social network data of Facebook, and then what I did is implemented the algorithm to implement the diffusion of technologies, and then to make it possible, I made the many helpful functions, and then as a result, I was able to get the nice idea of this social network data structures. Yeah, that's it. Thank you.